Assalamualaikum. Hi. Today we're going to learn chapter 2, quadratic functions, and we are going to focus on the roots of the quadratic equations. We are going to have three parts. In this video, we will cover part 1, which is to understand the sum of root and the product of root. Okay, in this slide, we are going to investigate the sum of roots and the product of roots of quadratic equations. So we have column for roots, and then this is a column for the equation be written in the intercept form, and this is the column for the equation be written in the general form. This is the sum and the product of roots. Okay, let's say we have number 1, the roots of 1 and 2. We can write the equation in intercept form as x minus 1 times x minus 2 equals 0. Then we can expand and get the general form.
Now, if we have roots of 3 and 2,
we can write the quadratic equation in intercept form like this, and we expand and we get in the general form. Okay, if we have roots of negative 3 and negative 1, so we can write in intercept form as x plus 3 times x plus 1 equals 0. And we expand the equation, we get this. This is in general form. And lastly, we can have these two roots and be written in the intercept form. And we expand, we get in general form. What I want you to focus on is the sum of root and the product of roots. So the first pair of roots is 1 and 2. The sum of them is 3 and the product is 2. For the second pair, where the roots are 3 and 2, the sum of the root is 5 and the product of the roots is 6. For the roots of negative 3 and negative 1, we get the sum of them is negative 4 and the product is 3. And lastly, for the roots of negative 3 and 2, the sum of them is negative 1 and the product is negative 6. Now let's focus on the sum of root first. Now, when the sum of root is 3, you see over here is minus 3. When the sum is 5, over here is minus 5. When this is negative 4, and in the equation is plus 4. When it's minus 1 or negative 1, in the equation is written as plus 1. Okay, we can see as if that the sum of root is written as the coefficient of x, but with the opposite sign. Instead of when the sum is positive, it's written as minus. When the sum is negative, it's written as plus. Yeah, it's the opposite sign. Now let's focus on the product of roots. When the product is 2, you see that here is also 2. When the product is 6, here is also. When the product is 3, in the equation, the 3 is placed here. And when the product of roots is negative 6, in the equation is placed here. So, from this pattern of arrangement, we can generalize that when we know the roots of quadratic equation, we can write as such that x squared minus the sum of roots here be the coefficient of x with the opposite sign here, plus the product of root equals to 0. Okay, let's say example number 1. Given 4 and negative 3 are roots of a quadratic equation, form the quadratic equation. Okay, earlier on we know that the quadratic equation can be arranged as such that x squared minus the sum of root x plus the product of root equals to 0. So here, since we already know the sum of root and also the product of root, what are they? So the sum of root is 4 plus negative 3 equals to 1. And the product of root is 4 times negative 3 equals to negative 12. After we get the sum of root and the product of root,
we can substitute them in the respective spaces.
okay, so we have x squared minus 1x plus negative 12. But you must remember that for the algebraic term with coefficient of 1, we can just omit the number 1. Just write x squared minus x minus 12 equals to 0. So this is our quadratic equation with the roots of 4 and negative. See example number 2. We are given with the roots of quadratic equation x squared minus 8x plus k equals to 0 are alpha and 2. So alpha and 2 are the roots of this equation. Find the value of alpha and k. What must we do? First, just write down the equation given. This equation is already arranged in the sum of root and product of root. We identify the roots are alpha and 2. We can compare the sum of root of alpha plus 2 with the sum of root in the equation. So the sum of root is 8. From there, we can proceed to calculate the alpha. Alpha is equals to 6. And then the product of root is alpha times 2 equals to 2 alpha. And we compare it with the equation. Product of the POR is equals to k. Since we already know the value of alpha, you just substitute alpha with 6 here. And we get k equals to 12. So solve our problems.
Let's move on to question number 3.
Given alpha and negative 3 are the roots of the quadratic equation 2x squared plus 5x minus h equals to 0. Find the value of alpha and h. So first, we just write down the equation. Now before we can identify the sum of root and the product of root, we must first make sure that the coefficient of x squared is 1. So here it is 2, therefore we have to divide all the terms with 2. So we get x squared plus 5 equal to x minus h over 2. All terms we divide with 2. So the purpose is to make the coefficient of x squared 1. So, alright. So this is already arranged in the SOR and POR. We identify the roots given in the equation. They are alpha and negative 3. And then we get the sum of them and the product of both roots. So the sum of roots, alpha plus negative 3, so alpha minus 3. And then we compare with the one in the equation. So in the equation, the SOR or the sum of root is 5 over 2. And now we can simplify and calculate the value of alpha equals to 1 over. Next, we go on to the product of root. The product of root is alpha times negative 3, so it's negative 3 alpha. It's from the roots taken from the question. And then we compare the product of roots from the equation, which is negative h over 2. Right, so we have negative 3 alpha equals to negative h over 2. Now, since we already know the value of alpha, we can just substitute alpha with negative 2 and we calculate, finally we get
h equals to 3.
That's all for today, and thank you for watching. I hope this video benefits you, and please remember to share and subscribe. Bye.